Now we're going to take a look at the domain of log functions. And in case anybody's out there thinking, why are we going to bother to look at the domain of log functions? We didn't bother to look at the domain so much of exponential functions. And the reason why we have to look at the domain of log functions is, let's remember the relationship between exponential and logarithmic functions. They are inverses of one another. So as I've written here, remember the domain of the exponential functions was negative infinity to positive infinity. That's why we didn't really, we did look in some examples, but it wasn't anything that required any deep thinking because they were always just negative infinity to positive infinity. And the range for exponential functions, that was limited, and generally without any transformations, it would be 0 to positive infinity. Well, because they are partners, this domain now becomes the range. So our range for the for the logarithmic functions is negative infinity to positive infinity. And now the range for exponentials, which was limited, that becomes our domain here. So that's why we take a look at the domain for log functions, because our domain is limited to positive values, values that are greater than 0, or x is greater than 0. Again, for functions not involving any kind of transformations. And we saw this when we graphed. So how do we do this? Before, let's remember, in the world of domain, most functions, the domain is negative infinity to positive infinity. Before we got to this world of log functions, the two kinds of functions we saw where there were limitations on our domain were rational functions, which involved denominators, so we had to kick out stuff that made the denominator 0. And the other functions were square root or any even root functions, where we had to look at what was under the radical and set that, similar to logs, greater than or equal to 0. So now we have a third scenario of a function where our domain is going to be restricted or possibly restricted. So in this first example here, log base 4, x minus 5, what we do is we take this, what's in the parentheses after the log, and we set it greater than, because that has to be bigger than 0. So x minus 5 is greater than 0. Add 5 to both sides, so x is greater than or equal to 5. In interval notation, that would be 5 to infinity. Remember the work we did in graphing these using transformations. This was our log function, picked up and moved to the right 5. So we're going to be starting at 5 to infinity. So if you're looking at the domain algebraically and you're not quite sure, picture what the graph would look like, or use Desmos to graph it to help you understand what the domain would be. Next example, we have log base 10, x plus 6. Again, we take what is in the parentheses after the log statement, and we have x plus 6 is greater than 0. Subtract 6 from both sides, and we have x is greater than negative 6. In interval notation, this would be negative 6 to positive infinity. Again, thinking about transformations, this log function has a horizontal shift to the left backwards of 6. So we're going to go back 6. So our domain now is going to start at negative 6 to positive infinity. Next example, we're looking at the natural log function. So base is e here. For terms of domain, it doesn't matter what the base is, because what we're doing is we're looking at what is inside the parentheses for the log function and setting it greater than 0. So we have 4 minus x is greater than 0. A couple of ways you could do this. The one way I'm going to do is subtract 4 from both sides. So we have negative x is greater than negative 4. I need positive x. So I'm going to multiply both sides by negative 1. And now I get x is and 4. And remember, when you multiply or divide by a negative number, this sign gets flipped. So we have x is less than 4. And in interval notation, x now is less than 4. We're going to have negative infinity to 4 as our domain. Again, thinking about the transformations here, notice the subtraction means we are going to reflect this over that y-axis. So we're going to be on the other side of the y-axis in negative x territory, and we're going to go from negative infinity to and stop at positive 4. This one isn't quite so easy to visualize as these two. If you did it on a graphing calculator or Desmos, you would see it. And this answer will make sense if it doesn't now. Last example, we're looking at the natural log, again, base e, x squared. So we set x squared has to be greater than 0. And if we think about this, any number except for 0 squared is going to be bigger than 0. So any negative number squared is a positive number. Any positive number squared is a positive number. So any number is going to work for our domain except 0, because 0 squared is 0 and we can't be 0. We have to be bigger than 0. So this works for any x except x equals 0. Another way to say that is x can't be 0. And in interval notation, this would be negative infinity to 0, and then 0 to positive infinity. So domain of log functions.